In this video, I'm going to be teaching you guys how to assemble your SAP2 assembly code. So we're going to be using a package on PyPy called SAP2 assembler, and it's made by me. So we're going to type pip install SAP2 assembler, and we're going to get the latest version, which is 2.2.0.1. That's the latest version. We're going to install that. And now if we type pip show sap2 assembler, okay, first you need to learn how to type, and you can see here it's version 2.0.1. I made it, and there's the location, and yeah. So that was the installation. To actually set it up, we're going to type null test dot py, and then we're going to make another .asm file, test.asm, and that's all we need. So you can see here test.py, test.sap2asm, and then in the terminal we can first we have to go to the setup, basic setup. We're going to type from sap2 assembler. We're going to import the sap2 assembler class, then assembler equals sap2 assembler, which it's basically we're creating the object. Okay, and then now we're going to say assembler dot assemble. We're going to assemble the test.sap2asm file, and we're going to take the output of, we're going to take the assembly code, not the machine code, and we're going to write that into output.txt. So if we run this python test.py, so it has created an output.txt, and this is the code. So this is the address in hex, and this is the actual assembly code. Now I'll tell you how you can modify the output. How will it show you the output, like how many bytes should it print and all that. I'll tell you about that later. For now, we can go to the test.sap2asm file. I can close this, and then in the test.sap2asm file you can type some mnemonics, like you can type move A into B, you can type move B into C, you can type decrement A. So let's try that. So it worked, and then if we go to output.txt, you can see here the move A to B is this, and then the move B to C is here, and then the decrement A is here. So that's 1 byte instruction, single byte instructions. Next we have labels. So I can say loop, and then we're going to just decrement A, and then we can jump to loop. So what that's going to do, it's going to decrement the A register, and then you're gonna jump back to this loop label, and it's going to keep decrementing the A register. Well, that is if you put it on an actual SAP2 machine or a computer. This is just going to assemble it. So we ran that and you can see here we have decrement. This is the decrement command, and this is the loop, this is the jump command, and we're jumping to address 0000. That would in hex, but here you're seeing it in binary. So next we have variables. So to define a variable, you can say x, that's a variable name, is equal to, this is going to be the address at which x is stored. So if you type $sign, it becomes the hex value, but if you type hashtag, it's binary. So I'm going to type $sign because I'm not writing 16 bits in binary. So we're going to store this at 000f, and since the SAP2 has 16 bits of address, so this would be this would be like 12 zeros and 4 ones. So after we define the address at which x is going to be stored, we can actually assign a value to x. So we can say x equal to, again $sign is hex and hashtag is binary, so we can put binary here. So if you want it to be like, let's say 5, you can actually type here, it would be like 00000101, that is 5. So now if we run this, so it would have stored at address 000f, it would have stored a 5, and 000f it stored 5. So that's how you make a variable. You can obviously have multiple variables, and you can reassign variables later in your code, and you can also reassign the value at, I mean the address at which they are stored. You can reassign that too if you really wanted to. And then after variables we have the directives. We have .org. What that does, it sets the origin. So basically if I say .org $000f, and then if I say decrement a, what this will do is at 000f it will write the decrement a command, or not command, the opcode. Then I can keep continuing. I can say decrement a again, I can say move a to b. So what this will do is, instead of starting at address 0000, it will start at address 000f, and it will continue to write from there. And you can obviously have multiple .org directives. Next is .word, and what that does, it's basically a 2-byte word. So we can say $00ff, and since we don't have a .org, it's going to start at address 0000. So if I run that, go here, we can see ff00, it's little endian format, so we have ff00. Next we have the .byte directive. So .byte, this is the same as .word, but instead of 2 bytes it's a single byte, so we can put 0f. Run that, you can see here we have 0f if you convert that to hex. And then we have .ascii. So if I type hello, so .ascii hello, it's going to turn hello into the ASCII format, and it's going to write that into these addresses. Next we have macros. So it's basically like a function, but instead of having your computer execute that, it basically just replaces the code. So if I can say here macro, okay, macro I can say, and I can give it a name hello, and I can say decrement a, and then I can say end macro to end the macro. And then if I call the macro hello, you can see here we have decrement a. So I can obviously okay, I can obviously have like a .org. We can put it at 000f or 000f, and then if I do this, now it will replace this hello with decrement a, and it will do it at address 000f. So that's macros. And next we have the different configurations. So let me just write a test script here. I can write let's say we're going to load a. First we're going to define a variable x is equal to we're going to put it at address 000f, and then x is going to be, let's say 0f, and then we're going to load a x. So that's going to load a from this, it's going to load from that address, and then it'll obviously be 0f. It's going to load the a into that computer, and then we're going to say store a, or we can first define a new variable y is equal to, we're going to put that 0010, we can store a into y. So what this will do, it will just set y is equal to x. So if we run that, we can go to output.txt. Here you will see x, which has been initialized to 0f at address 000f, and this is the LDA opcode we can see here, and this is the address at which x is stored. It's in little endian format, like I said. So it's 000f, and then we're going to say store a into 0010, which is what y, that's where y is. So after we do that, we can go back to test.py, and we can say, let's say hex data equals true. What this will do is, let's run it. It will print it in hex instead of printing it, or not printing, it will write it to the file in hex instead of writing it in the other, instead of writing it in binary. And then we have hex data, and then we can say, let's say row width equals, let's say 8. So now if I run this, it'll just print 8 will print 8 bytes, and then it will go to the next line and keep printing 8 bytes. So you can see here we have 0 address 0000, and then after that the 8 byte is address 0008, and then it keeps going all the way down, and then we can say n bytes is equal to, let's say 16. So this will just print 16 bytes. You can see it's just one line, 16 bytes. The default is 6, the row width is by default 16, and now the n bytes is 16, so it just prints one row. And then next we can even add, let's say we can print the data also, print data. So it'll print it to the, well, okay, we have to set it to true first. It'll print it here, and it will also write here. You don't have to specify an output file, that's just it's optional. You can just print the data directly to the terminal if you wanted to. And next we have, and then next I'm going to tell you about the CLI, or the command line interface. So after we installed it, you can see again sap2 assembler, pip show sap2 assembler. You can see here we have installed it. Then you will have a new command in a terminal, sap2 assembler. You can type -h for help, and you can see here the h is show help, the dot, the a flag, which is -a, it's the file to assemble basically. The .o flag, I mean -o flag, is a file, the file to write assembly code into, I mean the machine code into. -rw is the row width, -b is the number of bytes you want to print, -p is, print the data. No, -b is the number of bytes you want to either print or write into the file. -hd is hex data, like I showed. Yeah, and there's one more, -fo. So that's overflow, or no, yeah, overflow equals to, what this will do is, we have expressions. Oh, I forgot to show you that. We can have expressions. So store a y plus 1. If I run this, so you can see here y is equal to 00110. So y plus 1 would be 0011. So that's what will be here. Here is this, and then yeah, 0011, 0011. So you have expressions. You have expressions too, and let's say an expression results in an overflow. So you can type +255, and if this flag is set to false, not flag, in here it's just a parameter. If it's set to false, it'll print something. But if you set it to true, it will act as, it will technically it will act as if it overflowed. So you can see here, yeah, it overflowed. So what we did was, this plus 255, and it overflowed and it got us f0, it got us 010f. I don't know if that's right. So it got you that. And yeah, so if you want to do that in the command line interface, you don't need this. If you want to do it in the command line interface, you have to set the -fo flag. And that's it for this video. In the next video, I will be actually telling you how to make the bus of the SAP2 computer. And I have a challenge for you. I want you to make your own custom program and run it on this assembler. I showed you how to use it. Tell me about it in the comments, whatever you made. And like this video if you want me to do a video on how to add custom instructions or how to change existing instructions. Like if you want to change the opcode of the decrement A to fit your SAP2 computer, I can make a video on how to do that. But that's it for today. Okay, bye.